A very good evening to everyone of you. And today, guys, we are just going to see one of the awesome news and awesome discoveries that has been made by NASA and ISRO. And they just collaborated and they just built an advanced, so much advanced, a satellite called NISAR. And in this information, in this video, I am just going to tell why this NISAR satellite is so much important to us in today's society. And do you know, guys, this satellite alone costs nearly 12,000 crores. You just think of just one satellite costs around 12,000 crores. Even the Chandrayaan-2 and Chandrayaan-3 mission, it means the spacecraft, the rover, the Pagyan rover and other kind of the lander, they just mostly cost around nearly 800 crores rupees only. See, where is 800 crores and where is 12,000 crores? Both are contributing to each other. This 800 crores, they just landed in the surface of the moon and did a study for next, which means 1 or 2 weeks. After they just gave the analyzing data towards the ISRO. But you just see this 800 crores and where is this 800 crores and where is this 12,000 crores. So in this video, I'm just going to explain clearly about why they are constructing this 12,000 crores and why the collaboration between NASA and ISRO had occurred. Okay guys, we can just go into the video. So you can see in this information they just gave about why the ISRO is planning to launch the NIS satellite on July 30 on GSLV Mk-II rocket. So the most important is why they are using this GSLV Mk-II, because we do have two satellites, PSLV and GSLV, and now the next generation satellite launch vehicle is also being constructed. So this PSLV is so simple. So it means it's rotated depending on the polar way, and GSLV means geosynchronous orbit. So geosynchronous orbit means, let me explain by clearly explaining to you. So let us consider this is just a paper, though. So this is a Earth, and here the moon, it means here the sun will be, and you can see I think so. And according to the north and south, it will rotate here. But see, here the sunlight rays will be fallen, and here entirely it will be dark here, and here entirely light will be there. So it rotates according to the light waves. It means wherever there is light, it will rotate according to. In the dark region, it won't go, because in light, where there is light, we can get a clear-cut information, clear-cut picture upon it. So that's called geosynchronous orbit. So that's why it means this satellite is going to revolve around geosynchronous orbit. So that's why, and also they are using this GSLV. Why? Because this GSLV has capacity of carrying maximum 5000 kg of weight in low Earth orbit. Suppose if for geosynchronous orbit means it's capable of carrying nearly 2500 kg. It means plus or minus 200 kgs. So that's why they are using this GSLV Mk-II rocket. This is also highly advanced rocket has been constructed by the ISRO. So this NISAR means NISAR stands for NASA and ISRO. It is synthetic aperture radar. So what is the meaning of synthetic aperture radar means? So you just see this is the Earth surface, this is the Earth, and here the satellite will be. So let us consider this is the satellite, and here there are a lot of clouds. So let us consider here full of heavy rainfall. But down there is a lot of biological information, raw source and raw, it means raw, what to say, lot of materials or some other kind of thing which is considered. So most of the normal satellite doesn't have that much capacity to scan the entire thing that's been present below this raining area. But this synthetic aperture radar is so much advanced that it can send signal through the clouds too. And it means, because you just see in the clouds there will be lot of waters. Alongside there is a ionosphere. In the ionosphere, most of the ions are separated in a plus and minus. So it penetrates to the ionosphere and simultaneously to the clouds, and it just tracks on each and everything and also scans, and the same reply it will go to the satellite also. So that's why it is called a synthetic aperture radar. So these two biggest organizations work towards, and they just created this satellite. And why this is so much useful means, I will just show you one video in that you can clearly see why this is useful for earthquake, volcano, ecosystem, ice sheets, flams, it means farmlands, lands and landfill. Let me show you the video. So this is the video, you have to just see carefully. See, can you see that? I think so you can see that, because you just see this side of the portion, it completely shifts to the front side. You can see now, you just see again. Can you see it? Wow, see that. So this is one of the thing. See, because this kind of thing is caught on the camera, but before before catching on the camera, we can easily detect what kind of tectonic movements will going to occur, and if there is tectonic plate movement, if there is any volcanic eruption that's going to happen in the future, means this NISA satellite can be detected easily. So that's why it's so much special. So other thing is a dual band radar. It means dual band radar means they are using two type of radar. One is L band radar, next one is S band radar. So later I'll just tell you what is L band and S band radar, and see, you can see it will be able to see through clouds, and also both at day and night also it's going to operate. So it can operate at the both day and night, and in all weather conditions. Either it may be weather, either it means winter or rainy or any cloudy region or any kind of storm also it can easily operate. So this costs around nearly $1.5 billion. So it's a huge cost. And you can see the earth surface is constantly changing. It means national disaster, human driven changes and climatic shifts. A lot of other things also been coming up. And you, in the past few days, you would have known about the Himachal Pradesh condition. There are a lot of, it means rain bursts, cloud burst has been occurring. Cloud burst means so simple. Suddenly the cloud will accumulate in a one area, which you can see, suddenly the cloud will accumulate in one area, and suddenly the rainfall will come. So if per year, if for 1 year, there should be a rain of 100 millimeter, means for one instant, it means for in 1 hour itself 100 millimeter of rain will fall instantly. So that's called as cloud burst. So heavy rainfall at the particular expense at a smaller duration of time. So that's called cloud burst. So this kind of things it can be easily monitored by this NISR. And you would have known about the Himachal Pradesh, what happened recently, about the huge rainfall that has been occurred. So this kind of thing, it means the climate changing and critical information. So this kind, it can be easily observed and can give the data to us. So you can see the NASA and ISRO has created a powerful global mission, and this is a high resolution camera. So high resolution means you would have know, because the resolution should be so much high, it means so much precise and accuracy. Suppose if you have phone, means you just see how much pixel the phone has, and simultaneously you just see this is a satellite. Satellite means not 40,000 or 50,000 rupees cost of the phone satellite. It's nearly about 12,000 crores. So tremendous amount of money is spent in it. So the resolution will be so much higher. And see other changes, solid earth and ecosystem, it means all of the other things, it can be easily detected. And you see the tracking groundwater. So how much the flow, the groundwater is coming. So it can easily track and level of dams and other things. So the both the NASA and ISRO, they just told this mission will be for 3 years. They will continue monitor it for 3 years. And but the original lifestyle will be go to extra 2 years. So at least 5 years it will go. And the other thing is, suppose in case of scenario, if there is any satellite, it means any cyclone has came in a particular location, or any rainfall has occurred in a particular location, means so it means what the reality is, it means the officers or the workers, they will go to the location and they will start to investigate, and using the scanning or using the other kind of equipment, they will just go scan there, and after scanning they will collect the information and they will give it to the department, certain department. So it will take at least 1 or 2 weeks. But this NISR satellite will scan instantly. So within few hours data, the complete comprehensive detailed report will be submitted to the main department. You just think 1 or 2, where is 1 or 2 weeks and where is just a few hours. So that's why it's called as so much advanced satellite. And you can see once it is launched, NISR will enter the Sun-synchronous polar orbit. So Sun-synchronous means the sunlight, it means wherever the sun faces, the shadow will be there. Here full of daylight will be there. So in the daylight it will rotate. In the night, till now it has been not allotted for this, because they are launching in a sun-synchronous polar orbit at an altitude of 747 kilometers altitude. At inclination, it means degree of inclination is 98.4 meter. So it is a synthetic aperture radar, so bounces. So as I said before, this kind of thing that's been given here. These are not things I just told before itself. So in this, there are two type of antennas. It means one is passive sensor, and second one is the active sensor. So it's so simple, guys. So let us consider this is the earth surface. I think so you can clearly understand, because I don't have any kind of that animated videos or animated images. So that's why I'm explaining in a physically. So this is a ground and this is a satellite. You just consider. And what the mother thing is, here the sun will be. So sun will put the rays and it will get reflected from the ground, and the satellite will detect this kind of rays. So this is called as passive sensor. And simultaneously when you compare to the active sensor, so this is the earth, and you can see this is earth. So what the satellite will do is, the satellite will emit the waves, and after emitting the waves will be reflected. These waves will be captured by the satellite, and it will detect what kind of, it means the precise information, the each and everything, even the branches, even the leaves also, not like exactly the leaves, but even the branches are surrounding things, and so much accuracy it can detect easily. So I'll just show you certain kind of images so you can understand easily. Okay, I think so you can see here. So you just see, this is taken by the passive sensor. It means by the normal satellite. You can see here the here center, the river is going, and little bit of so much complicated things, small river. So you can see a small river is there. But you see in the this, it means in our satellite. So this is taken by our satellite. So you can see the mainstream. It means the main content, each and everything. Small areas also you can easily detect and easily can see. So that's why this satellite is so much important. And see, in this also, you can see in this also there is certain kind of river flowing here, but we can't see accurately and precisely. But you just see each and everything is so much accurate. So see here. So that's why this satellite is so much advanced and so much complicated to manufacture this. And this NISR satellite is consisted of two band widths. So one is the L band, and second one is the, this is S band. So L band, it's literally of higher wavelength. It means it goes around nearly 24 centimeter. Nearly accuracy means 20.5 centimeter. You just see guys, 24 centimeter. In your hand, just consider means this will be 15 centimeter in my case. And 25 centimeter means the one wavelength itself goes to 25 centimeter L band. And if it's S band means it goes nearly to 12 centimeter. So this both type of waves is used in this NISR. So most particularly one band will be L band satellite or S band satellite only they will use in one satellite. But in this satellite it means they are combining the both. This L band satellite is made by NASA, and this S band satellite is made by ISRO. So they are just both collaborating to it means to integrate in this satellite. So the other thing is, you can see in this there is given the L band and S band, and extremely sensitive to the biomass, better soil reliance, and see ionospheric noise. See, in the ionosphere is so much important. I think so you can see it's okay. This ionosphere, because in this ionosphere each and every ions get to separate. So that's why to penetrate the waves in this ionosphere is so much complicated. And about disaster management, agriculture, for this kind of other things we can easily understand. So the instrument is expected to operate in up to 70% of every orbit. So another one thing they are saying is, this satellite to come to the exact location. Suppose let us consider this is Earth. You can say this is Earth. So this is India. So just don't think in the wrong way. This is India. So for first day it rotates, and it just scans the entire India first time. So now the Earth is rotating. So you just think the Earth is rotating completely. So again now the Earth will be, it means the Earth will be other side, and here the other country will come. So to come to scan again India means it should wait for 12 days. So to track one spot, it takes next 12 days to track the same spot. So within, it means for one spot it rotates, and for next spot to scan the same spot means it needs extra next 12 days. So that's why they have been saying here. You can see here, for each spot on the ground will be scanned every 12 days. And there is another thing, it has considered 12-meter wide antenna. Wait, I'll just show you the picture so you can understand in a clear way. So now you can see, I think so. So this is a 12-meter, the whole biggest antenna. So what this active sensor will do, it will emit rays towards the ground, and again after reflecting it will capture to this antenna. So after that they will completely process and monitor and send to the data center that's been present in the Earth. So another thing is, for each time it sends the radiation, it goes and scans 1240 kilometers. So whenever it sends the signal, it goes and scans 1240 kilometers down and gets reflected to the same antenna. And after that, whatever is it, and it will go to, after processing, it will go to the data center that's been in the Earth. So another thing, see this is enough, I think so. Okay. and here they just given about what they will manufacture. This L-band SARs, and it means L-band is manufactured by NASA Jet Propulsion Laboratory, and this 4-meter antenna and all kind of other things they has been manufactured. And in the end thing, what they have given means, once NISAR is placed in the orbit, most of its data will be sent to the NASA's near Earth network in Alaska, Norway and Chile. So why they are sending this kind of information to Alaska, Norway and Chile instead of sending the data to particularly to the ISRO means, ISRO has a little bit drawback because ISRO doesn't have any kind of database or satellite database center in the North Pole or Southern Pole. So why this North Pole and Southern Pole is so important means, the satellite is rotating based upon the North Pole and South Pole and in a Sun-synchronous orbit. So here the Alaska will be there, here the other kind of thing, here Norway mostly here side, and here Chile something in the particular to South Pole and North Pole is there. So that's why they can easily process data and easily can collect the data. But since India is present in the main Tropic of Cancer, so that's why we are not unable to access the data easily. Suppose if we have any kind of data center in the Arctic region or advanced in the Antarctic region means, we can easily process the data. But see, you can see the ISRO also had a ground station in the Antarctica too, so that's why the most important thing. But when we compare it to their data will be so much sufficient. Now you can see 3 TB data is received per day. So that's why it's also so much important. So as I said before, 3 dB per second. So you can see the 3 dB of radar data. So per second, it means that used to scan and used to send. It's not a image data, it's not a other processing data, it's a radar data. So both are the different thing. A normal imaging scanning and other radar data is also a different thing. And after the radar data arrives, the Indian National Remote Sensing Center will process and distributes all products required to the Indian users, mirroring NASA's pipeline. So I think so now you will little bit understand about why this NASA and ISRO, this satellite is so much important to us. So suppose if you got any kind of useful information from this video, just put a like, and if you want, you just share this kind of useful information to your friends, or you just have a communication or have a discussion with your friends. So guys, let me see you in the next video. Then tada, bye bye, see you in the next video.